Good morning, everyone. Hi, I'm Daniel. Who was with me yesterday for Spring Security? Half of you. You came back. Not too bad, but not everybody came back. I'm a bit disappointed. For those who aren't here, I work for Broadcom in the Spring and Tanzu teams. In Spring, I do Spring Security things. So Spring Security, Spring Authorization Server, and so on. And in Tanzu, I do Applied Spring. So we take Spring projects and we package them into commercial products that we sell to customers. My socials are here. Feel free to reach out. I come here to conferences to chat with you, the community. So if you have feedback, questions, suggestions for improvement, you can always reach out. I'll take the time to answer. Maybe not within the week, but I will take the time to answer. So before we get started on this, just a quick temperature check of the room. Who's familiar with GraalVM here? 70% probably. Okay, cool. And who actually uses GraalVM? 1, 2, 3, 4, 5. And who uses GraalVM in production? 1, 2, all the same. Very good. So there's a lot to go through. We'll do a little refresher on GraalVM, and then we'll deep dive into how these limitations impact your Spring apps when you want to actually migrate, and then how you can get to production a bit faster with some tips. So GraalVM, I'm lazy, so instead of writing a slide, I copied the docs. Their docs are really good. You should go there. You should spend your vacation in the GraalVM docs. They explain all of the things, and they're very well written. Basically, for those who are not familiar, GraalVM takes your Java code, makes a binary and executable. So imagine an exe file on Windows that you send over to your coworkers by email, and that it gets blocked, so probably not. So if you've never used GraalVM, they have a Hello World example in their docs, which is actually quite good. So in here, right, they have a Hello World, which you can compile with a regular Java compiler. So if you run it with Java compiler, it takes less than a second. And then I can run this compiled Java code and I get Hello World. Since I'm using Java 22 with GraalVM, this one here, I have another binary that's called native image, which takes a Java program, bytecode, and then compiles it to this native executable. So the first thing you can notice when you run this is that it's taking infinitely much longer than compiling Java code into Java binaries. It takes a lot of resources too. And it analyzes my code. And then in the end, in 18 seconds, it produces an executable. So this hello world I can run now. Can't really tell the difference. If you time and you look at the resource consumption of these two approaches, the hello world from Java takes about 60 milliseconds to run, 137% CPU at the top, and then 75 megs of RAM. The same, but for the compiled binary, this time, it takes less than 10 milliseconds. It takes about half the CPU and only 5 megs of memory. So far, it just like only wins. It's faster, it's much lower in resource, and the only price we've seen so far is the compilation time. But that's a hello world, and it already takes 20 seconds to compile. So if you have a bigger Spring app and you want to port it, you can imagine it's going to take more than 20 seconds. And if you have to iterate on that, it's going to be quite painful. So you want to keep your build times as low as possible while you're making the migration process. 2 tricks for that. 1, use the latest and greatest Graal release. So currently it's 22. Even if you don't deploy with that version in production, because it's not approved by the company, while you're developing locally, using the latest will squeeze 10%, 15% of compile time. So it's actually pretty good. The second trick is when you run native image here, while developing, you can set the optimization level of what Graal will do for you. So by default, it optimizes at level 2, but you can tell it do as little optimization as possible. And this one will actually still be slow, right? Elevator music, but it will be faster. So from this, we'll see how long it takes, but you can shave So 11 seconds. I can't remember which 18, it was 18, so we removed 7 seconds out of a 18 seconds build, which is quite good. You don't want to send that to production though, because it's less optimized, but for iterating, moving your app, -OB is the way to go. So pro tips, Java 22, soon Java 23, and then OB for optimized builds with little optimization so it goes fast. All right, so if you've ever heard of GraalVM, and I imagine most of you have, there's this closed world assumption that we go on and on about. GraalVM only takes the code your app needs to run to put it on a binary, so that it's smaller than a JDK. My hello world here is big, but it's only 5 megs, and a JDK is or a JRE is 70 megs or something. So in order to achieve that, it basically gets into your main method. It looks at the code you call, the code that this thing calls, and then it goes all the way down and it only takes the parts of the code that your application is going to use. But that comes with limitations. So strong limitations on things it can't do out of the box without some config and without some help. For example, JNI, if you're calling C code from your Java, it's going to be a bit complicated. Reflection. So if you parse a string to run some code, then the GraalVM compiler doesn't know how to put that in your binary because it doesn't execute. The compiler doesn't execute the code. It just looks at it. It looks at the abstract syntax tree. So it doesn't know how to do reflection, proxying, toying with the class path. All of that is, you have extra work to do. So what does that mean in practice? In Spring, the biggest impact is going to be proxies and reflection. Because, for example, the IOC container, so the core Spring framework, when you do beans, components, they're wired together, and this is achieved by reflection. And so if you had to do this manually, there's a lot of classes in Spring, and you would have to go through a lot of steps to find out what should be included and how can you include it. When you know what you want, GraalVM has this reflect config JSON that you can feed. Let's take this one, why not? So it's a big JSON file, and it instructs GraalVM of all the classes and methods you want embedded that are going to be called by reflection. So this is useful because it can't find them automatically. If you feed it that, then it's going to include these classes for you, and they will be able to work as you expect. So Spring has a processing step when it compiles. So I can kick off a compilation here. Gradle. Ooh, I'm in the wrong directory. Gradle native compile. Compile. There we go. So it has a process AOT. So it has an ahead of time step where it would analyze your code, analyze itself, and then produce some of these files for you. So in the generated directory here, when Spring process AOT, it will generate a reflect config for you, right, with all the things it needs by reflection. For its injection, its IOC container for bean injection, the way to make it work is it creates some more classes for you so that instead of doing analysis of your app at runtime, looking at annotations and loading those, it will produce some code that's imperative and register all the beans using methods. So for example, I have a, say, book controller here. So this book controller takes a few dependencies, book repository, Hugo word service, and so on. And so in here, Spring will generate a class for me that tells the Spring container how to generate one of these book controllers. And this is just calling a method. Oh, okay, so how do I create one of these? Then I create this, I call new on it, and then I pass a book repository, a Hugo word service, and all forms of classes. So if you want to find out which beans end up in your app, you can find them out in this generated sources that Spring creates for you. For libraries, so that are not Spring, So think, I don't know, Flyway for database migrations. There is a community repository, GraalVM metadata repository, this one, that basically lists all the libraries that are compatible and that have done this work for you. So they've created their own reflect config. So I was mentioning Flyway here, say core. And so all of this can be pulled into your app because they have done the work of making their lib compatible with GraalVM. If it's not in here because it's your code, you would have to write your own reflect config, which is a bit of a pain. So in here, reflect config. For libraries, we have the GraalVM metadata repository. If the lib is not in there, you're going to have to do some extra work. And then Spring will help you quite a lot by doing this AOT processing step. But what about your code? So how do you make that work? Where do you have reflection in your code? Do you know where you have reflection in your code usually? In your own user code? Anybody has an idea? Annotations? In annotations, yes, because you're going to be scanning the class. The biggest thing that people will find out usually, I think, is strings. So anything that is a string that contains code, when you think about it, some Java code is reading a string and saying, oh, you have a book here and it has a method called title and I want to call that one. Well, I have to find this book type and I have to find a title method on it and I have to launch it, right? It's not a compiled binary. And so anything that's template or is the Spring expression language is going to be a problem. And the second biggest problem is usually marshalling or serialization to another format. So you take some Java code and you make JSON out of it, or you take JSON and then you load into Java code. Well, again, it's manipulated in a string. I'll have a JSON blob and it has a property, and I want this property called foo to go into the foo field of the bar class. So I need to find the foo field in the bar class and set the value. So these are the biggest instances of serialization. So I can show you the little toy app I have for this. I'm going to run it on a different port, so it doesn't clash with the native one. 8081 Gradle boot run. Okay. So we have localhost 8081. So it's a small app. It has a list of books. You can go on them, see the details. You can call another microservice that runs in Docker now that gives you the list of the latest Hugo Awards. There's an admin page where librarians can go and delete books from the collection. And of course, because everybody does enterprise work, there's an export button that produces an Excel file using Apache POI. So, an Apache library to create Office documents. It takes a little while to launch. Well, you can either trust me. Oh, here it is, right? So I can produce Excel. Fine. Okay, so if I try and run this with GraalVM, so I've compiled my app, as I told you, right? I ran native compile. It did the AOT phase, in which it brings up the app without starting it, just to analyze the beans and produce the reflect config, produce the bean definition. Then it calls GraalVM. So this is what we've seen with the Hello World example. And then in the end, it gives you a books. It's in build, native compile, books. I can run the app. So this one, it starts in less than 100 milliseconds, whereas the Java one is 4 seconds. But it has a lot of problems because I get an error. Of course, I'm rendering a timeleaf template here. And in my timeleaf template, I have to zoom out to find out the problem, but zoom a little bit more out. There we go. So in here, it says the method called slug cannot be found on the book type. So when we're evaluating book.slug here in the template book list, it's not working because my book type is a user type, and GraalVM doesn't know that I'm going to run reflection on it. So to instruct GraalVM that I want reflection, I could write a reflect config JSON, which is a bit of a pain. Instead, what we recommend and what we offer in Spring is we have this concept of a runtime hints. So we're going to give hints to GraalVM that we want this to be registered. So import runtime hints, and we're going to create book runtime hints.class. So you'll see it implements this runtime hints registrar. Yep, amazing. And so in here, I can say, I want to do some reflection. Please register for me the type, it's called book. So the book.class. And what type of reflection am I going to do on this? Am I going to do constructor? Am I going to do scanning? In here, we're looking for public methods and, public methods and probably public fields, right? So with this, if I compile again, my book type will be registered for me. So we've seen the first problem, which is this book list, right? This calling a template. There's another instance of string. If I try and go to admin, I need to be authenticated. So I try and authenticate here, right? And then I get another 500 error. And in that case, that's because my book controller has this Spring security expression here. And so this expression, what it says, ooh, I want a bean that's called librarian service, and I want to call is librarian in it. Well, this librarian service is just one of my classes. IntelliJ can find it. It has heuristics to say, oh, that's this one, but GraalVM can't. So I would have to register that one for reflection too. So on the hints, again, I could do hints.reflection, register type, librarian service, class, and then public methods, right? And so you can register the full type, you can register some methods, you can be, very broad. If you want to register everything, you do member categories, category dot values, and it registers everything for reflection. And then the last bit that has a problem is calling a microservice. So in here, I'm calling this Hugo microservice, another 500. And if we look at the details of the error in here, zoom out. So it's actually slightly nicer. Come on, there we go. So it says I can't create a Hugo award service API response because I can't bind. And if you actually read the message, it will tell you in here, this appears to be a native image, in which case you may need to configure a reflection for the class that is to be deserialized. So you would need to go and say, oh, this is Hugo award service. And what's happening? Well, we're calling an upstream microservice. We're mapping the JSON result into a class. So this class and its subclasses need to be registered for reflection. So with these book runtime hints, reflection, register type, API response. Let's register everything, or everything. And so do the same for the subclass that it uses, or not the subclass, but the nested class it uses, and so on, right? So here's how you would register your things for reflection. This one, cool. So when you are using reflection and you don't know you're using reflection, beware everything that is string that may contain code, which is usually Spring expression language templates, everything that does JSON. So when you have a REST template, a REST client, a web client, and you map to a class, when you have an object mapper and you call write value or read value manually, anything that does class scanning, so if you're doing like WebJS locator, that's not going to work. And then not incompatible libs, we'll go into that a bit later. Spring will help you with runtime hints. And there's another way, if you don't want to go into this runtime hints, you can say, oh, register this class entirely, which is register reflection for binding. So any configuration class, instead of importing a runtime hints here, you can say register reflection for binding. I want to register, say, the book class. And so this is a shorthand for registering book for reflection for everything. Okay, one little, silver lining to this is that if you have an endpoint and that this endpoint produces JSON, so for example, I have this API book endpoint, it produces a type here, book API response. This is a Spring managed method, and in its signature, anything that is either in the output type or one of the request body, Spring will know that you will want to serialize to JSON or deserialize from JSON or XML or whatever you use. So this book API response is already included. You don't need to do that yourself. So, this is producing JSON, but you don't have to do the registration manually. So for controllers, repositories, everything that's managed by Spring, you're covered. All right. Everything else, I'm not going to demo everything else, but basically if you have some files that you need to embed, you need to be explicit about it. So if you have, I don't know, some CSV template you use to generate stuff, then you want to tell the GraalVM that you need this. So in the runtime hints, again, you can also do other things such as hints.resources, .resource bundle, like foo.txt, right? Add foo.txt to my image. Spring will give you for free everything that a normal Spring app needs. So application YAML, the templates when you're using a template engine, the schemas for the database, migrations. It will give you the banner.txt, the common file, Spring factories. You can find those. It goes into a metadata file generated for GraalVM in AOT resources here called resource config. And so this resource config will tell you, oh, application anything.properties is included, application anything.yaml is included, the banner is included, the templates, the static files that you want in your app. So you can find what's included here yourself if you're curious, but usually, unless you do very custom stuff, it's not going to be a problem. If any of your class must implement serializable, and that's not very often, you need to declare that. It's a different type of serialization. We're not serializing to JSON or mapping between formats. This is Java raw serialization. So in here, you can declare a class for serialization. Oh, I don't know, the book class again to be registered for serialization. This is possible, but it's not common. The only thing that I can think of, apparently Job Runner has some cases where it serializes Java objects to disk or to bytes that it stores in a database, but you won't encounter that very often. And then JNI, anybody does JNI here? Right, no one. Oh, yes. Well, let's chat at the end, I'm curious. And then Java agents. So when you want observability, you have your Datadog agent or whatever, you usually add that at runtime. So you run your boot jar and pass in an dash agent. That's adding code at runtime, which doesn't work with a pre-compiled binary. GraalVM supports that if you pass the agent at build time. So I need to use this flag in the native image compiler so that this agent code is included in my binary. If the agent is crazy and it does modifications on your code, it's not going to work. But for a basic agent that just adds features, this is usually fine. And there are a few other known limitations which you can go and find out on the Spring Boot wiki. So with GraalVM, it tells you all the things, right? So log4j2 is not supported in native images, for example. Okay. Okay. So we've seen how what the usual problems are, and then how we can fix them. But if you're if you're iterating over your thing because you can't find your app is huge and you can't find all the things, you will be entering a very slow feedback cycle where you make a change, you compile, you go and you hit the endpoint, and then it explodes and you see why it explodes, and then you register the thing for reflection, then you compile again and wait for a minute, and then it's long. So what I recommend, what I use for migrating apps is I do Gradle native test. So this is a combination of Spring and JUnit. It produces a binary from your JUnit tests. So the binary that comes out of here is not your app, it's actually your tests. And you can run your tests in like 10 milliseconds. there are a few caveats to this. For now, the biggest problem is going to be that Mockito is not supported. They're working on support. It's going to be, hopefully it's going to hit soon. But that means any slice test that you use that has a mock bean or a spy bean in it is not going to work. And then the big second caveat is if you're doing integration tests with test containers, that's not supported either. Anyone use test containers here? Yeah, right. So it's usually useful. So to go over this, two things. One is if you have a Mockito test, let's say this Hugo Awards or test containers. Let's go to the test. Hugo test. This one. So you can take a test. Oh, it's already highlighted here, and you can say disable that in native image so that this test doesn't run because it's never going to work. It uses test containers. That's not supported. So remove this test. And so if you still want to have some tests so that you don't have to launch the app and go click on things again. So my recipe for that is I write a specialized version of this test. I call it native. And so this one doesn't use test container. It uses Docker Compose. So in here, we have a hard-coded URL. So it's a very special setup where I launch my Docker Compose, and I do, in my test, talk to an instance of a microservice. And I say, I just want this to be enabled in native image. So this test will only run when it's a native image. So this should be done here, right? So if we zoom out, we'll see that it's compiling all my code and then it's running the tests and we can see the details. So for example, Hugo Awards native test debug, this one didn't work. And so if I scroll, I'll find something, or this title enhancement. The title enhancement method, it failed because we were evaluating a Spring expression language expression that uses title enhancer, and I have not registered title and enhancer. So in here, I can have a good overview of what's failing, and then I can iterate fast. So what you should aim for if you want to use that as a feedback mechanism is you want tests that have good coverage, that try and touch every path in your app, and then introduce a few dedicated end-to-end tests that actually exercise touching the other systems. Because at the boundaries, usually there is serialization happening and you may be missing something. Anti-goal of these tests, it's not made for thorough behavior verification. The feedback loop is a bit longer than what you would get for a Java test. And so it's not meant to check that you break business behavior. It's meant to check that you're not breaking like native image specific things. And so you don't necessarily need to run this on every build. It's more expensive. You may need other systems. Maybe you don't want to run this in CI. Don't go telling my boss that I told you not to test or not to test often. What we're doing here is this is a second type of test. You still have your Java test. You still have your integration normal test. This is just a feedback tool for compiling to native and migrating an existing app. For the rest, keep testing as you do. Everybody does tests here. I'm not asking the question. Come talk to me for support if you are not allowed to write tests. Okay, one last interesting point on Spring is some Spring annotations have impact on which beans get loaded at runtime, which you can use to control your behavior. So notably, what developers use the most explicitly is the profile annotation. And also you can have this conditional on blah, 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 conditional on missing bean, conditional on property. So there's an example in my code. Let's go to the configuration class, configuration, book, configuration maybe. There we go. And so in here, there's two things. There's the title enhancer that has a fun profile and a not fun profile. So the fun one, you get an emoji because the emojis are fun. Otherwise, you get the serious one. And then there's a English book repository and a French book repository. So if I pass books.lang to fr, I get the French books. And otherwise, the default is the English book repository. So we can see the difference by running this JVM app. I can pass it profile. So Spring profiles active equals fun, and then books lang equals French, we run the app in Java, right, in the JDK mode. There we go. And here, if I go to localhost 8081, the books are different, right? Now this is Planet of the Apes, Ravage by Barjavel. And so now I have funny emojis. Very good, very good. So different types of books and different title. And this shows when the app starts, right? It says the following profile is active. We have the fun profile, so we'll have emojis. Amazing. Spring detects that in native. So if I run Spring profiles active equals fun in the compiled books build native compile books, right? So when it starts, it actually tells you, hey, there's a fun profile here, so we're going to have emojis. Well, no, you're not. Sadly, 80. Oh, I should register real things I haven't built. Let me put my hints, prepared runtime hints, fix all the reflection. There we go. Security runtime hints.class. So while this is compiling, here, native compile. So while this is compiling, you can actually see that in here, I have a log line that tells you which type of beans are included. And in the title enhancer, I have the fun profile, but I get a serious title enhancer. This is because when I compiled my app, Spring started the context and then detected which beans I wanted. The profile was not fun, so we put the serious title enhancer. And this you can see in the AOT preprocessed classes, the AOT sources here in this bean registration. If I look for a title enhancer, this one here, I can see how this would be constructed if I want to debug why this is this way. And this is going to go into the book configuration and call the default, because that was the profile at build time. This may be a problem for you if you rely on profile or if you rely on properties. It means first, if you, for example, you rely on dynamic behavior that Spring Boot gives you. For example, if I enable Spring security auth to client to do auth to or OpenID connect login. If I don't have those properties, Spring will not wire the beans for me. But locally, maybe I don't use that. Maybe I use a local login, and only in prod do I use the auth to login. When you compile, you need to put the properties that will have the same shape as what you have in prod. So you put in your application YAML, when you compile, you say Spring security auth to blah, 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 client, and then you don't have to put the real values because we're not launching the app. We're just looking at the properties, which allows Spring Boot to decide that it's going to wire a client registration repository for you. So you need the same shape of properties that goes into the app. If you have profiles, and you need that because you're doing, for example, I have a profile for staging and I have a profile for prod. Basically, this means, well, I have to have a binary for staging and a binary for prod, so I need to compile twice. It's a bit of a pain. One hack you can do, if you really need this, you don't necessarily recommend you do this, but one thing you can do is have one bean that's activated not by a profile, but activated all the time, and just select which type of bean in your code so that GraalVM can find it. So basically here, I have one title enhancer bean. I have no profile, but I pass in the Spring application environment. And with this environment, I can have the active profiles. So in here, I can test on this. So does it contain fun? And if it contains fun, I return a new emoji title enhancer. And so when GraalVM Spring AOT will add this bean to its bean registrations, and then GraalVM will find this, and then we'll say, oh, in here, you're going to need this emoji title enhancer and serious. So you'll have both classes inside, and you can decide what you want to launch. And so use this, with parsimony, but it can help you avoid having to double compile. Okay, so anything that's profile or conditional on, be aware of that. Anything else, it's fine. So anything that is not conditional and that doesn't impact which classes are loaded, is fine. So if you have an add value, this will work. We're seeing it if we're doing, this should be compiled now. So books build native compile books, right? So if I run this with, I think it's called books title, my thing. Hello. Title, thank you. Hello, Devox UK. I'm not even sure the thing is called like this, but if I run this and I go to AT&T and books, 5th season. No, it's not called that, but like values will work. So if I do server port, right? So server port I know is going to work. Server port, boop. I can still run my boot app on port 1234. This is fine in here, right? Because it doesn't impact the classes which are loaded, it just impacts properties. Anything else? Configuration, controller, component, service, whatever. This is fine because it's not conditional. It's just loading the class. Okay, so we've seen reflection. We've seen dynamic annotations. But what about unsupported libraries? That's the most fun part. So, because I like pain, I asked, which libraries are, which are the pain points when you compile to GraalVM, and someone told me Apache POI, which is generating Word, Excel documents from Java code. And so oh yes, everybody does Excel from their app. If you do business, like you export to Excel and you make colors, and it's really great. So when I click on this, right, of course, it's not running because it's 1, 2, 3, 4. But if it's running, and I go back and I do this, I get a 500. And typically, if I want to go and debug this, I can the same way we've done earlier, right? So I can go in here, find where it explodes, and it says in somewhere in Apache POI XSSF, something exploded, and I'm missing the class org Apache XML beans implementation store locale. So I could go and register that with reflection. But if I do it, I will guarantee you that when I run, I have another problem, another class, and I can go and register that class and so on. It's going to take me a very long time. So instead, what the fine folks at Oracle give us is an agent that you use to analyze your code in Java at runtime and generate the metadata. So, remember we've seen the reflect config, we've seen the resource config, and it's going to generate these files for you based on the code that you actually use and how reflection is used. So if you use Gradle, which I do, yeah, okay. So with this, I can run, I can run a boot app with boot run with Gradle. Same goes for Maven, I do Spring Boot run. In Gradle here, if I have the dependency on GraalVM, I just pass the agent profile, and it runs normal app. It's a bit longer because it instruments my code. Docker Compose comes up. Amazing. And so in here, in localhost 8080, this is the Java version of it. I can click export. I get my export here. When I stop this, in my build directory here, I have this native subdirectory, and it has agent output. And in here, when I ran boot run, and the session that ran at this time, so I guess now, right, 8:38, it's 9:38, it generated all these files for me. So if I go to reflect config, the problem we had, remember, was something locale, that one. So we're missing Apache XML beans implementation store locale. It found that for me. So it's a huge config though, right? And you're going to be pulling a lot of classes, including some duplicates that come from Spring. It's not the leanest way of doing this, and you can apply filters, and there's a lot of work you can do to make this smaller so that your resulting binary is smaller. But it's a very good first approximation. So the trick after this is you take this. This looks really good. I'm going to take all of this and put it in a new directory in my resources here. Directory, and it's called meta inf native image. And I do what we developers are best at. Copy, paste, right, add, boom. And so I'm going to start a compilation again, native compile, and then we can chat about the details after this one. And so it's going to ingest these files. The GraalVM native image compiler is going to find all the things that were used. The problem with this is also you have to hit all the endpoints of your app. You can run the agent on your tests. So if you have good coverage, you can generate these files with your tests. So while this is compiling, do check the compatibility. For example, Apache POI, if you add it and you build your app and it's so cool, and then you try and compile and it fails, and then you go into their Jira and they tell you, well, we use log4j2 now, and log4j2 is not compatible at all. And the plan of the folks at log4j2 is, yeah, wait for log4j3. So latest Apache POI wouldn't work. So do some research before when you have unsupported libraries. If you want to check which libraries are supported, we have the metadata repository we've seen. Here's the, not this one, metadata, this one. In here, you have the list of all the third-party libraries that are supported. So org.apache, yeah, we have Apache stuff that's promising, but there's absolutely no POI here. So sad face. You may have a problem. And then you have some corner cases. So for example, while building this, I want to auto-size the columns on my Apache or in my Excel spreadsheet. For some reason, Apache POI uses the abstract window toolkit from Java, AWT, which you have not seen in 25 years. That's not currently supported by GraalVM on macOS. It works on Linux, it works on Windows, it won't work on my Mac. So you may have some caveats that you want to find out in advance. And then for everything else, you use the tracing agent. So with Gradle, P agent, with Maven, P native, D agent equals true. And then if you're just running a Java, if you want to run the jar, you can pass more configuration with the agent lib like this. And so hopefully this is compiled. Beautiful. So if I do books, and so on, now hopefully localhost 8080, I click export. Aha! And in native, I have my Excel. Amazing. No work, just run the agent. Okay, so last little caveats and things to keep in mind. Packaging and distribution. So my Mac it's a Mac, and it's an M1 CPU. So it's an ARM architecture CPU. In here, I have, say, the target machine, which is a Ubuntu that runs on GCP, I think. And it's an x86 machine. So if I take my binary here and I copy it, and I test the conference Wi-Fi, so I wouldn't be able to do this demo, but because I know conference Wi-Fis, I'm familiar with conference Wi-Fis, I have a pre-uploaded version of this. So I already did that from my hotel room. So if I try to run this native Mac app pre-uploaded, no, unhappy. Can't execute, it's the wrong format. This was compiled for macOS, not for Linux. And even if it was Linux, my thing is an ARM processor, so it wouldn't work on an x86 machine. And even with ARM, you may have different versions of the ARM instruction set. So to go over this, basically, you want to compile on your native on your target architecture. So if you're going to run on this type of machine, compile this on this type of machine. Same if you want to run Ubuntu, or if you want to run Alpine, you kind of want to run build on an Alpine, because it have a different libc implementation and it's dynamically linked, so you may have run into problems. So some caveats. I think the best answer for this, for you to go to production, is to actually just use build packs. So Gradle, build image, or Maven Spring Boot build image. Ooh, conference Wi-Fi warming up. Let's go. So in here, right, I have Gradle, I have Spring Boot. So if I do build image, it will do the right thing for me. It will build an image for Ubuntu that I can run on Ubuntu or on Linux x86-64, which is the target that you usually use. I'm not going to wait for this to build, but so that you don't have to think about it yourself. And last bit, trade-offs, right? We mentioned performance and how GraalVM can help us have instant start time and low resource consumption. So if we want to see this in, oh, look, it has copied, amazing. If we want to see this, my Mac it's a huge machine. It's very fast. So if we want to see this, I'm going to pretend that I'm a smaller, smaller VPC on a cloud that has, just one core that's much less powerful than what I have. And so I can limit the CPU of what I'm running. And so let's run books, build, native compile, books. So I can run this app. So yeah, you can see here it's not as fast to start up. It's not less than 100 milliseconds. It's a bit slower, but still it's fast. If I do the same for the JDK, which I try there, CPU limit 2%, and then Java jar books build libs.jar, right? So this is the Java one, and you can already feel, and it takes a little time to warm up. So 4 seconds instead of 700. So if I am in an elastic environment, I'm on Kubernetes, I want my pods to come fast, this is not great. And that's a small app, so a bigger app will take longer. And if I try and do some performance test against them, so I'm running this locust performance. Think of Gatling. That's performance test written in Python, so load tester. I'm going to pretend I have 16 users, and I'm going to target the GraalVM implementation. So start here, and then some nice graphs. So first, it takes a little time to warm up, but that's the Python. That's not GraalVM, because it's doing averages, but almost immediately, it flattens out at its peak performance. So in here we have 4,800 requests per second, give or take, and the peak latency is 95th percentile is 5 milliseconds. It goes really fast. If I were to do this against Java, I run it again on the same graph. So a few glitches that are due to the tool, not due to Java. And then, so it's an average, it's going to change slightly, but when the JVM starts, here we get 700 requests per second instead of the 4,800 that we had here. The latency is 14 milliseconds with peak at, or 95th percentile at 82 milliseconds. But as opposed to GraalVM, Java optimizes over time, right? It looks at your code and it gets better with whatever code path it finds you actually use. So the trade-off here is like it will start really fast, instant peak performance. So you get like the peak of all requests you can make, and it's much less resource hungry. It runs on smaller nodes. The JVM will scale better over time, unless you do some special stuff. If we wait long enough, the JVM's like smokes my naively compiled GraalVM thing. So if I'm good with the optimizations, if I use GraalVM Enterprise Edition, which is free if you're doing a SaaS, the licensing prohibits you to ship the binary. Someone use them on their machine, but if it's in your server, it's free. We'll get pretty close performance, and then we can do more stuff. But out of the box, here we get 6,200 opposed to 4,800 here. So again, trade-offs. And with that, I hope you learned something. My socials, reach out, questions, and this hopefully is the link to the feedback form so I can get invited again. Come on, do it. Yeah, all right. Cool. We have 1 minute left for questions. Does anybody have any question? Yeah.
Why can you not run the thing you ran on fully on Log4j to see what's Log4j doing?
It's doing a Lambda meta factory to like generate methods, and so GraalVM has no plan to support that for now. So that's a JDK feature that is just not supported. No plans, no immediate plans.
Sorry, I was giving feedback.
Log4j2 is not supported because of the Lambda meta factory, and I think
Different Lambda names.
yeah, it's and I don't think it's a plan. So there are some things, but wait for log4j3 or downgrade to log4j1. All right, cool. Time's up. Thank you, everyone.